Okie dokie. In this problem, they ask which of the following graphs is the graph of this function. The first step I would probably take is to plug in x equals 0 to this function. What that will do is find us the y-intercept of the function. In other words, the place where the function crosses the y-axis. So to plug in 0, we will get negative 0 cubed minus 6. Basically, all this stuff will just go to 0 because 0 cubed is 0, and then negative 0 is just 0. So really, we have 0 minus 6, which is just negative 6. So the f value, or the y value, is negative 6. In other words, the y-intercept is negative 6 because it was the y value for which x was equal to 0. So which of these graphs has a y-intercept of negative 6? It looks like A is a contender, B is a contender, C is not a contender, that's positive 6, so that's out of here, and then D, also positive 6 for its y-intercept, so that's not our answer. So next up, you could try is thinking about what the shape or what the behavior of these curves must look like depending on what the leading term is. So in this case, we have a negative x cubed. So it's helpful to know what cubic functions look like. So I'll go over those first, and then I will address the even functions that you might also see as well. All right, so for odd functions, if you have a positive x cubed, the end behavior, or just like the look of the graph, will be something like this. So they might often describe the end behavior as like lower left and upper right, like as it goes to negative infinity, it's going down, and then as it goes to positive infinity on the x values, it's going up forever, something like that. But I might just think about it like this, something like that. And then for a negative x cubed, it's just the opposite. It's like the flip, so it'll do something like that, roughly. So it starts upper left and then ends lower right, something like that. So in this case, if we have a negative x cubed graph, we know it's going to look roughly like that. My sketch is not very great, but hopefully it's enough to identify B as the answer. Now for even functions, even powered functions, right? Positive x squared is like a parabola that's opening up. Negative x squared is a parabola that's opening down. So you want to look for that behavior if that ever comes up. But I also want to mention this kind of applies to really any even powered function. So you could have not just x squared, but even x to the fourth, x to the sixth, whatever. They might not look like strict parabolas like this, but maybe if it's x to the fourth, it might look a little more flattened out at the bottom, a little less curvature, if you will. Something like that, you know. Anyway, so it still has the same, like, if it's positive, it's up, up, and if it's negative, it's down, down, something like that. Let's go ahead and do a few more examples here. So starting with this one, let's go ahead and find the y-intercept. So by plugging in 0, hopefully you don't have to think about this too much. Really, just whenever we plug in 0 to any x term, it's just going to zero out that whole term. So we're really just going to be left with whatever value we see next to it, right? So just positive 2 for the y-intercept here. It looks like this has positive 2, this has positive 2, this is negative 2, and then this might even be positive 2, which is kind of annoying, but that's all right. So we have 3 contenders here. And then we have a negative 2x to the fourth. So the leading term is a negative x to the fourth, negative 2x to the fourth. So if it's negative x to the fourth, let's refer to our little sketch here. Negative x to the fourth, the end behavior should be down, down. So it should almost look kind of like a parabola, but because it's x to the fourth, it again should be a little more flat and a little less curvature at its, you know, vertex, for lack of a better word. So anyway, it's opening down, so we know we can eliminate C. And then when we look at A versus D, we can tell that D has more of a curvature, so D might actually be like a negative x squared, while A is likely a negative x to the fourth type of function. So A is our best choice here, and that's pretty much it. For any of these problems, if you wanted to, just as a reminder, you could really, you don't have to worry about like end behavior stuff. If you really wanted to, you could just plug in different x values and see what their y values are and see which graph makes the most sense given those y values. So what I mean is, like, we could have also confirmed that A is our answer by, say, plugging in x equals 2. If we plugged in x equals 2 to this function, let's think about what we would get. 2 minus 2 times 2 to the fourth. 2 minus 2 times 2 to the fourth. 2 to the fourth is 16, and 2 times 16 is 32. So 2 minus 32 is negative 30. So the idea is like when you plug in x equals 2 and you get a y value of negative 30, which graph has that ordered pair? Well, really the only graph with a y value of negative 30 showing is option A. So that's kind of another way to narrow down those answers, or maybe just approach this problem in general. So let's maybe try just that. I might just try that approach for all these. How about let's make up a new approach. Let's just plug in x equals 2 and see how that goes. So negative 2 times 2 squared minus 1. You also just want to make sure you plug this in correctly, obviously, but this might work every time, maybe. So, might work every time, maybe. Very unsure. I'm just doing this off the fly here, on the fly. So, let's keep evaluating this. We plugged in 2. We got this. Then 2 squared is 4. Negative 2 times 4 is negative 8. Minus 1, negative 9. So the idea is at x equals 2, do we see a y value of negative 9 for any of these graphs? 2, negative 30 down here, that's way too small. 2, negative 9-ish right here, right? Okay, that might be a contender. And then 2 is like positive 9 for that one. And then 2, like positive 30 for this one. So I think just plugging in 2 and getting a y value of negative 9 shows us that C is our answer. All right, that's pretty fun. All right, I have one more. Let's see if this method works as well. Let's plug in x equals 2, and we get 2 cubed plus 6. 2 cubed is 8, plus 6 is 14. So the idea is we are looking for a y value of 14 at the x value of 2. So at 2, we have a negative value here. Nope. 2, we have probably about a 14 right there. That's looking pretty good. And then at 2, we have maybe like a 2 right there. That's not it. And then at 2, we have a negative value. So that's not it. So just like that, we can see that B is our answer. So we kind of covered a bunch of different ways to go about this in this one video. I'm assuming you might have to know just the end behavior things, like with the even functions and the odd functions. So I would keep those in mind. However, for this problem, again, you can just plug in x equals 2 and identify your answer like that. I hope that helped. If you have any questions, let me know.